We're going to do some more work with the power rule, but just add on a couple other components to it, starting with the constant multiple rule. So the constant multiple rule says if C is a constant, then we're going to use the d over dx notation again. D over dx of C, the constant, times the function is equal to the constant times the derivative of the function. I think this will make more sense when we look at a few examples. So we'll start out with 2x cubed. We now have that coefficient in front, that constant. So my C here is now 2, just to highlight that for the first one. When we take the derivative and we're bringing that exponent in front, we're going to multiply by the 2. So we'll do 3 times 2 to get 6x, and then take 1 away from the exponent, so 3 minus 1 is 2. Really not much different than what we did in our previous examples. But let's add on some with the negative exponents and also the radicals, just to get some more practice with that. So the next one will be 4 over x. Remember, the first thing we'll want to do is rewrite that with a negative exponent. This assumes x to the first, even though technically it won't be written there. So I'll make this 4x to the negative 1. Then to find our derivative, we'll multiply our exponent times our coefficient. That will give us negative 4 in front, x to the, and then we're doing negative 1 minus 1 to get our new exponent of negative 2. So I'm just doing this off to the side just to remind you of what you're doing. And then same thing as before, we want to bring that entire x to the negative 2 to the bottom of the fraction, make the exponent positive. And then we'll do one example with a radical before we move on to our next rule. This one will be 5 cube root of x. So we did one with a square root. When we rewrite cube root, remember the 3 in here, the index, is going to become the denominator of your fraction exponent. So this will be x to the 1 over 3. And then when we take the derivative of that, we're going to do 1/3 times 5. So we'll get 5/3 in front. And we will get a negative exponent when we do 1/3 minus 1, which is really 3 over 3. We get negative 2/3 for our exponent. And then again, just be careful when you're moving this to the denominator of a fraction, you're only moving the variable, but preserving the number in front. So we'll keep the 5 on the numerator, 3 is on the denominator, and we'll have x to the positive 2/3 down in the denominator with that. Right now we're ready to combine our rules together with multiple parts. And it's really not much different than what we were doing, but combining 2 or more functions together. So this rule is called our sum difference rule. For 2 functions, f and g. And in fact, this would work also for more than 2 functions, but we'll define it with the 2. D over dx of f of x plus or minus g of x is equal to the derivative of f of x plus or minus the derivative of g of x. So really, all this is saying is to do each part separately, as long as you have just adding or subtracting. We'll take a look at 3 more examples for this section also. And you'll notice your practice is mainly going to be the combination of this sum difference rule with the 2 previous rules that we just looked at. Okay, so this actually really has, if you think about it, f of x, g of x, and maybe h of x, because we have 3 different parts to it. When we take the derivative, we're going to do each part on its own. So when I do derivative of 3x, that's just going to come out to be 3. Then when I do derivative of negative 2x squared, I'll bring the 2 in front, multiply it, so minus 4. And it'll be x to the first, because remember we're subtracting our exponents by 1, which is why on the original, with the 3x, the variable disappears, because it becomes x to the 0. And then our last one, 4x cubed, will be plus 4 times 3 is 12 for the coefficient, and then x squared when you take the exponent down by 1. And that is your entire final derivative. So it's really just taking each of the pieces and finding those derivatives. And my second one, I have to do something to it in order to get the different pieces. This one is 2x minus 5 squared. I have one function inside being squared, but if you look back up, my rule is only talking about adding, subtracting. It doesn't have anything to do with the squared. So what I'm going to do is multiply this out first. Remember, this just means 2x minus 5 times 2x minus 5. And you recently had a lot of practice with foiling with the formal definition of the derivative. So this comes out to be 4x squared minus 20x plus 25. And now we have our different pieces that we can take the derivative of. So we'll go in order. The derivative of 4x squared will be 8x. And then the derivative of minus 20x will just be minus 20. And then our last part here, the number has no variable with it, so the derivative of the number is 0. We don't write anything in the final answer for that, it just looks like it disappears in our final result. And then one last example just to refresh the negative exponents. 2 over x minus 4 over x squared plus 5 over x cubed. First thing you want to do anytime you have those fractions, rewrite everything with negative exponents. So this will be 2x to the negative 1 minus 4x to the negative 2 plus 5x to the third. Sorry, negative 3. And then our derivative will be multiplying all those exponents by the coefficient, subtracting by 1. So be careful because we are starting with negative exponents. The number should get bigger in that negative range. So bring that in front, negative 2, x to the negative 1 minus 1 will give us negative 2. Our next one, we're multiplying negative 4 times negative 2, so it'll be plus 8. Subtracting 1 from negative 2 gives us negative 3. And then our last one, 5 times negative 3 will be minus 15. And then x to the negative 3 minus 1 will give us negative 4. And then our last step here, so we change things to negative exponents, and then we're switching them back to positives at the end. Everything goes back to the denominator. Remember, just the variables. Keep the numbers on top. And all of our exponents now go back to being positive. And that is our final answer. So that concludes the second video. You will now have a chance to try some practice on your own to see if you understand these rules. Make sure you go back to your notes and look at some similar examples to help with the practice.